Hi guys, this is O-Level Chemistry paper 12, June 2017, question 1. The diagram shows four pieces of apparatus that are used to measure the volume of a gas or liquid. Which piece of apparatus should always be filled to the same level? Now, burette, gas syringe and measuring cylinder have graduations on it, which means it has got different markings, which means they can be filled to different levels and can be used to obtain different volumes of liquid or gas, whereas the pipette has only a single marking shown, which I have highlighted here with an arrow. So the pipette must always be filled up to this mark in order for it to be used accurately. So which piece of apparatus should be always be filled to the same level? It should be the pipette, making option D the correct option for this question. Question 2. The diagram shows the structure of two forms of carbon. X is the representation of diamond and Y is the representation of graphite. Which of X and Y conduct electricity? Diamond does not conduct electricity because every carbon atom is bonded to four other carbon atoms, and graphite does conduct electricity because every carbon atom is bonded to three other carbon atoms, and one electron per carbon atom is available to move freely. So X will not conduct electricity, eliminating options A and B, and Y will conduct electricity, eliminating option D, making C the correct option for this question. Question 3. An aqueous solution of zinc chloride is tested by adding reagents. Which observation is correct? Acidified aqueous barium nitrate when added to zinc chloride forms a white precipitate? No. We do not have sulfur present, so this test is incorrect. Next, aqueous ammonia forms a white precipitate soluble in excess of the reagent. Yes, this is a confirmation of the presence of Zn2 positive ions. Then we have aqueous sodium hydroxide forms a white precipitate insoluble in excess of the reagent. Zinc ions will be soluble in excess of the reagent. Calcium ions will be insoluble. Powdered copper forms a gray precipitate. Copper is less reactive than zinc, so copper will not displace zinc in zinc chloride, so this reaction will not happen. So the correct option for this question is option B. Question 4. The statement about the particles F negative, Ne and Na positive is correct. They all contain more electrons than protons. They all contain more neutrons than protons. They all contain the same number of electrons. They all contain the same number of protons. So for these three particles, F negative, 19 mass number and 9 atomic number, neon with a mass number of 20 and an atomic number of 10, and Na positive ion with a mass number of 23 and an atomic number of 11. We will need to find out the number of protons, neutrons, and electrons. So the number of proton is equal to the atomic number. So for fluorine, it is 9, for neon, it is 10, and for sodium, it is 11. Number of neutrons is the mass number minus the atomic number. So 19 minus 9 gives us 10. 20 minus 10 gives us 10, and 23 minus 11 gives us 12. So this is a neutron number, and number of electrons is the proton number and the charge that is present, accordingly adjusted. So fluorine has a negative charge, so 9 plus 1, 10. Neon, we have 10, and sodium has 11 and a positive charge, so 11 minus 1, 10. So now we have the particles for each of the species provided. Now let's look at the options again. They all contain more electrons than protons. So 10 greater than 9, 10 equal to 10, and 10 less than 11. So option A becomes incorrect. B, they all contain more neutrons than protons. So 10 greater than 9, yes. 10 equal to 10, and 12 greater than 11. So this is incorrect. They all contain the same number of electrons. So 10 for fluoride ion, 10 for neon, and 10 for sodium ion. This is correct. And the last one, they all contain the same number of protons, 9, 10, 11. They all contain different number of protons. So the correct option for this question is option C. Question 5. The table shows some properties of four substances. Which substance is an ionic compound? So an ionic compound would have a high melting point. So high melting points are 801, 842, and 3000 is very high. 3000 could be a giant covalent structure, but let's continue. So option A has been eliminated. Then conducts electricity when solid. Ionic compounds do not conduct electricity in the solid state, they conduct electricity in the molten and the aqueous state. So do not conduct electricity is present in B, whereas conducts electricity is present in C and D. Both have been eliminated. So B has already been chosen as the correct option. But let's look at what the other column say. Dissolves in water. Ionic compounds do dissolve in water. Not all of them, but if it says it dissolves in water, then we'll accept it because some do, some don't. Conducts electricity in the aqueous state? Yes, they conduct electricity in the aqueous and the molten state. So all the properties shown for ionic compounds are correct in option B, making option B the correct option for this question. Question 6. Four samples are spotted onto chromatography paper. It is known that one of these samples is pure compound Q. A separate sample of pure compound Q is also spotted onto the paper. The paper is placed in a solvent. Which statement is correct? Sample 2 has traveled the furthest and sample 3 is pure compound Q. So pure compound Q will only contain a single spot. So the single spot that travels the equal distance as compound Q is present in sample 2. So sample 2 has traveled the furthest? No, that would be sample 4. Sample 4 has traveled the furthest. And the sample 3 is pure compound Q? No, that is sample 2. Next, sample 3 has traveled the furthest? No, sample 4 has. And sample 2 is the pure compound Q? Yes. Sample 4 has traveled the furthest? Yes. And the sample 1 is pure compound Q? No, sample 2 is pure compound Q. And the last one, sample 4 has traveled the furthest? Yes. And sample 2 is the pure compound Q? Yes. So option D is the correct option for this question. Question 7. How many of the molecules shown contain only one covalent bond? Okay, Cl2. Cl is a covalent bond. H2. Hydrogen has a single covalent bond. HCl. H and Cl has a single covalent bond present. Nitrogen have a triple bond between the atoms. And O2, oxygen has a double bond between the atoms. So, how many of the molecules shown contain only one covalent bond? So that would be chlorine, hydrogen, and HCl, making option B the correct option for this question. Question 8. Sulfur is in group 6 of the periodic table and has 6 outer shell electrons. Yes. And the question was which statement about sulfur and its compounds are correct? Okay. So the next one, in hydrogen sulfide is H2S. Sulfur shares one electron with each hydrogen atom. So the formula for H2S would be H single bonded to sulfur, single bonded to hydrogen. So sulfur shares one electron with each hydrogen atom. Yes. And sulfur dioxide is used as a bleach. Yes. So all three statements concerning sulfur or its compounds are correct, making option A the correct option for this question. Question 9. 50 cm cube of 0.1 mole per dm cube silver nitrate is added to 150 cm cube of 0.05 mole per dm cube sodium chloride in a beaker, as well as solid silver chloride. What is present in the beaker after the reaction? Okay, so AgNO3 reacts with NaCl, producing AgCl and NaNO3. So now the concentration and the volume 0.1 moles are present in 1000 cm cube. So how many moles would be present in 50 cm cube? So this would become 50 upon 1000 into 0.1, giving us a value of 0.005 moles of silver nitrate. Now the calculation for NaCl. We have 0.05 moles of NaCl present in 1000 cm cube of the solution. How many moles would be present in 150 cm cube of the solution? So the calculation would be 150 divided by 1000 multiplied by 0.05, and this would give us a value of 0.0075 moles of NaCl. Now the moles of NaCl are greater than the moles of silver nitrate, and since the molar ratio of reaction is 1:1, that means all of the silver nitrate will be used up and some of the NaCl would remain. So if we subtract 0.005 from 0.0075, the quantity remaining would be 0.0025 moles of NaCl. So that means NaCl is in excess. So it would be present after the reaction is complete. So now let's look at the options. Aqueous silver nitrate and aqueous sodium nitrate. Silver nitrate will not be remaining after the reaction. It is the limiting reactant. So silver nitrate would be used up. Sodium nitrate would be there along with NaCl, which has not been mentioned. So option A is incorrect. B, aqueous sodium chloride would be present. Yes. And aqueous sodium nitrate. Yes. Along with AgCl. And they have mentioned AgCl in the question itself. So this option is correct. C, aqueous sodium chloride only. No, we would have NaNO3 also present in solution. And for D, aqueous sodium nitrate only. Sodium nitrate would be there along with NaCl and of course AgCl in both the cases, C and D. So the correct option for this question is option B. Question 10. Nitrogen monoxide and oxygen react to form nitrogen dioxide. What is the maximum volume of nitrogen dioxide that could be obtained when 1 dm cube of nitrogen monoxide reacts with 2 dm cube of oxygen? So the molar ratio of NO is to NO2 is 2:2, which is the same as 1:1. Therefore, if we have 1 dm cube of nitrogen monoxide reacting, the volume of nitrogen dioxide produced would also be 1 dm cube according to the molar ratio, irrespective of how much oxygen is being used up. The minimum amount of oxygen required to produce 1 dm cube of NO2 would be half a dm cube because the molar ratio of NO to oxygen is 2:1. So we have 2 dm cube of oxygen being used. So oxygen is already in excess. So we would have 1 dm cube of NO producing 1 dm cube of NO2. This results in option A being the correct option for this question.